So before I start this class today, I do not ask you carry out this complicated calculation by yourself, but at the end, of this lecture notes, I have written explicit mathematical input. If you are able to find a way to run a mathematical program, but I heard that mathematical Wolfram Alpha is free to use, just like ChatGPT. You just copy and paste of this program and find out how I calculate the 9,000 something digit of square root of 2. Later, we will also compute this pi and the Euler number, but usual computer does not produce the correct answer. So if you make use of palm top calculator, it is impossible to produce this kind of accurate result. So I'm not really use this very, very accurate number in most cases. A few digits are enough. And in physics, the most accurately measured physical values are up to 8 digits. But this is just a theoretical fun to compute whether computer can carry out this kind of calculation or not. So please do not spend too long time to reproduce this result. But actually, I asked my son, who is a computer scientist, so, who graduated from the University of Toronto, and his major is computer science, and I asked my son to ask ChatGPT whether it reproduces these numbers or not. And my son told me whether he's not sure whether he to copy these digits accurately or not, but answer of the ChatGPT was wrong at 1,000 first digit. In addition, I asked him to ask ChatGPT how did he calculate that number. But that answer is, wait a second, I can find my son's reply. Wait a second. Hmm. I don't find it, unfortunately. But anyway, the ChatGPT says it is to computing the square root of 2 by more than 1,000 digits is a time-consuming job, and so actually ChatGPT did not compute anything, and he copied somebody else's result without referring in a correct way, and that's it. So you don't trust by 100% of ChatGPT or computer, but I'm always using computer as well as by hand, and computer is a very nice tool to do a tedious job without making any error. Only if you order it in a correct way. If you order a computer in a wrong way, it will produce wrong results. So let's start it today. The simple way to compute square root of 2 in a very, very accurate way. As I already told you, in solving physics problems, we are always working on mathematical language, and many problems in mathematics problems originate from physics problem. And for example, what is this is 1 centimeter. 1 centimeter area of this square is 1 square centimeter. So I'd like to enlarge the length of each side to have A and A. I want to know the value, the length of A to make this area to be 2 square centimeter. That's my question. And this is our problem. Okay, a simple way to find out the answer is factorization. The reason is that we know the real number, square of real number is always a positive. And if I have a product of two numbers to be 0, it becomes very simple to solve. The answer is A equals 0 or B equals 0. A trick to find out the answer in an algebraic way is this one. This one includes any powers. For example, so we have a square root of 2. We are looking for square root of 2. That is a solution of this. Okay, first of all, move this one to the left-hand side by subtracting both sides with 2. Then we have retrieved a squared minus 2 equals 0. We know how to factorize this using a squared minus b squared equals a plus b and a minus b. This expansion and factorization formula you are familiar with from middle school. So we define the solution, positive solution of this quadratic equation to be square root of 2, and negative of the solution to be negative of a square root of 2. All right. By the way, we'd like to know what the numerical value of a square root of 2. As you find at the end of this lecture note, the value is 1.4142, and so on. So many digits. So what should I do to find the correct value? Sure, square root of 2 itself is the correct value, and it is an exact number, but I'd like to compare this number with anything else that I'm having. So it is good to find an approximate value. Approximate value. That means if you use the digits, the 1.4 something, then if you increase the number of digits, you increase the accuracy. For example, 1 and 0.1 and 0.01, it decreases by a factor of 1/10. So if you increase the number of digits, then your approximate value becomes accurate as possible. So at some point, we truncate this series at a satisfactory level of accuracy. This is first step to find out the answer. Let us divide into the main part. Main part means your best guess and error. And we'd like to absorb error term as much as possible to the main term, and we find a systematic way to decrease this error term, monotonically decreasing. This is a way how to do that. First, at least it should be a sum of two numbers, and we can expand this guy, expand x squared 2xy plus y squared. Haha, we find this is the dominant term contribution. For example, at least we know it is near 1.4 because we know 14 squared is 196, is very close to 200. So we begin with this number as a starting point. In that case, we have an error of 4 out of 200. That is about 2%. So we have a number, small number y, that has an error of 2%, but I have squared in the next term. It is evident that y squared term, it's much smaller than this. Okay, that's the basic idea of finding an approximate value that approaches eventually arbitrarily close to the real value, actual genuine value of the square root of 2. So we repeat finding the better approximation by repeating this step. Therefore, it is better to introduce a sequence for step 1, step 2, step 3. So as you increase this index of this sequence, this error term decreases monotonically small. Okay, once you find some, here we have 196 is a square of 14. That is very close to 200. But as you know, this is an error, but we identify that error, and this error will keep decreasing. All right, so that is basic idea. First step, we begin with 1.4, that is 14 divided by 10. So why don't we substitute this 196 is 14 over 10 square. And we can simplify the 7/5 square. At least it is exact square root of 2. Square is 2. Therefore, it is a little bit smaller than the genuine value. So we have this inequality to find that there is some error. Okay? This is a dominant value, but we have an error, and we do not know what exact error is. As soon as we know the exact error, we have finished the game. However, we only know the approximate value of error. So we would like to increase this and decrease y1. So that is this method. At first step, it should be the same as a square. However, we know this y1 square is much smaller than y1 because we began with a very close value to square root of 2. So why don't you neglect this guy? If we do not neglect this one, we had to solve the quadratic equation, but solving the quadratic equation involves square root of 2. So we'd like to omit that part. So we admit our mistake, but controllable mistake and controllable error. So we admit we ignore this small term, but as soon as we ignore this, we can determine y in a completely algebraic way. Algebraic way means we can add, subtract, multiply, and divide. Simple calculator can be used to find this value. So if as soon as we ignore this higher order term that is assumed to be small, then this error. Now I have renamed this guy y1 with the y1 bar because it is not exactly the same as the correct value because of the neglection of this guy. So this approximate value of y1 is called y1 bar, and middle school student can solve this solution. So just 2 minus x1 squared. x1, what is x1? It is already known. Just to substitute, and we find out the error term. This error term is not an exact one because I have neglected this one. By the way, that error keeps decreasing. That's the fact. Okay, let's see what happens in the next step. We began with the main value that is a original approximate value 7/5. 7/5, but I have found the approximate value for our error. Now redefine this guy by adding these two. I have approached the genuine value a little bit more in comparison with original guess. So our better guess is 54/35. And then we redo the calculation to find the x2. How? Now I have a better guess for square root of 2, so I claim this one to be the main value. And then I look for another step. So this was this, and I combine this one to have x2, and at x2 I have another error, and I will compute y2 and so on. Once I determine the value of x of n, and then I can extend the calculation by neglecting the yn squared, and again we can determine this value and then substitute this one to find the next accurate, more accurate result, and repeatedly. So actually I do not carry out that explicit calculation. I can order either ChatGPT or any computer that can carry out this calculation. So they do the job, they do the 3D job, difficult, tedious. I don't like to do that, but I want to find the answer. Then in that case, I can use computer. So in this manner, I can repeat the calculation to find out the next order error. I can analyze the behavior, trend of the changing the errors in the next step. And if you follow this calculation, at the end of the day, you will find the scale. This guy, the next order one, is always much smaller than the original one. And finally, the answer is like that. All right, so as a result, using the previous result, I can claim that I can improve our approximation by decreasing the error term, monotonically decreasing. This is the result that I have obtained, and that this result can be obtained by running this program. This output will give you how much this error is decreasing, how fast it decreases. So as you can see, so step 1, we began with 1.4, and then step 2, 3, very, very large number. From step 6 on, I can produce the number, but it is this paper is not wide enough to write them down. So my idea is to find out the size of error term. I began with the 170s. Remember, our first step calculation, our error was a 1/70th. So begin with the 1/70th. Step by step, you can see the powers 10 to the 18, remarkably increasing accuracy. Okay? And I subtracted the computed approximate value by exact square root of 2. This is still fine, a very small error, but if you increase one step, it becomes 10 to the 9th. Just one step, you have a billion, factor of 1 billionth. Whoa, and then there's a factor of 2, factor of 2, factor of 2. This is the remarkable feature of a geometric series. Okay, so it depends on the computer power or the memory or something like that. But I have tested with my computer in my office. I produced 9,407 digits at step 13. I could have obtained a much more accurate result if I began with more accurate. Okay, anyway, in any step, its power is doubled. So remarkably accurate result can be produced. Okay, so in this manner, we can always compute an approximate numerical value for square root of x in a systematic way. The one we can learn from this today's class is that square root of 2, that is exact and is easy to write and easy to remember. It is a very busy and dirty. I have no way to remember this. So writing square root of 2 is a much saving our time. However, in an actual calculation, at some point we need to find the exact numerical value. In addition, there are many students from computer department, and if you carry out some numerical calculation repeatedly, computer makes a round of error, and that round of error becomes enormously large, and in that case, at some case, it produces absurd result. Just nothing we can trust. For example, in a computer carry out a computation with a numerical calculation, it has a range. For example, if you use the integer, there is some number, max int, maximum integer defined. In mathematics, we can assume there exists infinity, but in fact, computer has its own physical dimensions. We do not have infinite space, so we need to cut somewhere. Because of that, numerical calculation carried out by any computer need repeated addition and subtraction. So it is truncated at some point. But if you keep computing, adding and subtracting many numbers, For example, 10 to the 23, this is Avogadro's number, so addition, subtraction, final result is absolutely wrong result may appear. So you should be very careful. At least you should know controlling error with algebraic way is possible, and any computer is built equipped with this method, but limited way. My way of computing is a very inefficient, but eventually ChatGPT or any computer built-in program does not produce this. At some point, your brain should work to find a way that computer cannot carry out. Okay. Instead of asking many difficult questions regarding what I have presented today, so the next beta 4 main problem is just a simple geometric series. From geometric series, you can increase the number of terms to find, in case R is, this common ratio, absolute value of the common ratio is less than 1, the geometric series becomes arbitrarily close to some number, and error becomes very, very small, as you have seen, something like that. So even though you only remember in high school mathematics, this is a simple formula. This is exact formula. So I will ask many questions from this elementary formula. So that's it for today. Thank you.